Today we're going to look at something called permutations and how they relate to probability. So let's start with the first question. You are at a sandwich shop that offers the following for their lunch special. You can choose one type of bread and one type of meat for $1.99. How many different types of sandwiches can be made? And there's many ways that you could figure this out. You could make a table, you could list them, many different ways. One way that I can think of is by just drawing lines. So if we have white bread, we can choose turkey, roast beef, or ham. So there's 3 different options. And if we have wheat bread, we can also choose turkey, roast beef, or ham. So if we count all the different combinations here, or all the different sandwiches that can be made, there are 6 types of different sandwiches. So that is called the counting principle. If there are A ways to make the first choice, and B ways to make the second choice, and C ways to make the third choice, then you can do A times B times C times however many choices there are to get the possible number of outcomes. So possible outcomes. So that, again, the counting principle. If you have A ways to make the first choice, B ways to make the second, and C ways to make the third, you can multiply them together. So here for the different types of breads, there were 2 different types, 3 different types of meat. You can multiply them together and see that there are 6 sandwiches possible. Let's try another example. Suppose the set of license plates has any 3 letters from the alphabet followed by any 3 digits. Okay, so let's underline this. Any 3 letters, any 3 digits. How many different license plates are possible? Okay, so we have 3 letters, and we're going to multiply them together, and 3 digits. We're going to multiply them together. And the counting principle says you count how many there are and multiply those together. So we know that there are 26 letters in the English alphabet, and there are 10 digits from 0 to 9. That are 1-digit numbers. And so if we multiply all those together, we will get 17,576,000. 17,576,000 different license plates that you could make. What is the probability that a license plate has no repeated letters or numbers? Okay, so again, we have our 3 letters, we have our 3 numbers, but now there's no repetition. You can't use the same letter or number twice. So if there are 26 letters and we use 1, how many are left? Well, there's going to be 25 left. And then if you use 2 of them, there's 24 left. And the same for digits. From 0 to 9, there's 10 digits. But if you use 1, there's only 9 left. And then if you use 2 of them, there's only 8 left. So if you multiply those together, now there's only 11,232,000 different license plates that you could make if there was no repetition. So that's the counting principle when you can multiply these different events together. In a permutation, you can make arrangements without replacement. In other words, if it is used, it can't be used again. In other words, order does matter here. So this is kind of like the second problem that we just did for the license plate problem. Without replacement means you can't, if you use something, you can't use it again. So let's take a look at how we can solve permutations. So here's the first example. 7 orchestra members are performing in an ensemble. The names of the 7 performers are listed in the program in random order. How many different ways could they be listed? So the counting principle says, all right, you got 7 different orchestra members, and you can't use, if you use, if one person is sitting down, so you have 7 choices for the first name in the program, and if you use one of them, how many do you have left? You have 6 names to choose from. And if you use 2 names, you have 5 names left to choose from, and so on. And if we multiply 7 times 6 times 5 all the way down to 1, there's a faster way that we can do that, and it's called factorial. and factorial is an exclamation mark. So when you see that, it means you start at 7 and you multiply it by every whole number after that, all the way down to 1. So in our calculator, it's actually programmed in. If you open a calculator page and press 7, and then menu, probability, and there's that factorial. So 7 factorial will multiply 7 times 6 times 5 times 4 times 3 times 2 times 1. And the answer is 5,040. So there are 5,040 different ways to list the 7 performers. What is the probability that the names are in alphabetical order, assuming they all have different names? Well, there's one way you could put them in alphabetical order out of 5,040. So if we divide 1 by 5,040, it's 0.000198. If we change that to a decimal, it's about 0.02%. So I should say about 0.02%, that they are in alphabetical order, if you just drew the names randomly. After the performance, the players are backstage. There is a bench with only room for 4 to sit. How many different seating arrangements are possible? So here you only have 4 seats, and again we can multiply. 7 people have a chance to get the first spot, then 6 times 5 times 4, and we can multiply those together. But there's another way to do this, and it's using the permutation button. So a permutation, here's the actual formula for it. It is n factorial, which is n is the total number of things, over n minus r factorial. And, okay, so what these stand for, I should write them over here. So n is total number, and r is how many you're choosing out of. So here we chose 4, so the number you choose. So in this case, it is 7 factorial over 7 minus 4 factorial. What does this mean? 7 factorial over 7 minus 4 is 3, so 3 factorial. And let's write out what this means. It means 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. And we have a bunch of factors here that are the same. And we know that if we have a 3 divided by 3, that's 1. A 2 divided by 2, that's 1. A 1 divided by 1, that's 1. And so look at, we have 7 times 6 times 5 times 4, which gives us this right here. Now there's another way that you can type this in your calculator. It's NPR. Okay, so NPR means, all right, so again here we have 7 orchestra members and we want a permutation of 4. So let's type that in our calculator. So if I go to menu, actually we have to type the number first. So 7 members to choose from. Go to menu, probability, permutation, and then, oh, okay, so I'm sorry, I forget. In this calculator, you do that first. So we went to menu, probability, and we did permutations. And it tells you what order to type them in. So NPR means 7, and out of those 7, we're choosing 4 of them. And we get that 840. So that multiplies 7 times 6 times 5 times 4 for us. Okay, but now the next question is, what's the probability that the group of 4 sitting in alphabetical order? So again, there's one way to put them in alphabetical order, over 840. And so if we divide that out, I don't know what that is, let's double check. So 1 divided by 840. So about 0.119%. We can simplify with this factorial notation. So again, remember what factorial means. It means if you start at 4, you're going to multiply all your whole numbers down to 1. So this is 4 times 3 times 2 times 1. Again, in our calculator, it is 4, menu, probability, factorial, 24. So 4. And we could have done that ahead. 4 times 3 is 12. 12 times 2 is 24. Now, in our calculator, we can do 7 factorial divided by 6 factorial, but think about what this means. It means 7 times 6 times 5 times 4 times 3 times 2 times 1 over 6 times 5 times 4 times 3 times 2 times 1. A bunch of things cancel, and we're just going to get 7. So this is 7. Again, you could type it in your calculator, but it'll be faster to do it this way. So this one right here, it's going to be 10 times 9 times 8 times 7 all the way down to 1 over 8 times 7 all the way down to 1. So if you think about canceling everything all the way down to 1, we have 10 times 9, which is 90. Again, in your calculator, you can do it if you forget that. It's 10 menu probability factorial divided by 9. No, it was 8, wasn't it? So 8 menu probability factorial, and we get 90. So here's just the shortcut way to do it. Think about what it means. You can cancel a bunch of 1s and solve. All right, let's try some more examples of permutations. Let's say there are 30 people in the class. If each must give a presentation, how many different ways can the students present? All right, so this is 30. So so there's a few different ways to do this. Out of 30 people, we're choosing 30. So on our calculator, that's NPR. 30 out of the 30, you're choosing 30. Or this is 30 factorial, which means 30 times 29 all the way down to 1. This is probably shorter to do, so on our calculator, let's try that. 30 factorial. Okay, so it's a really, really big number. So I'm not going to write that down. If there is only time for 10 people to present, how many different possibilities are there? So to write it out a few different ways, we can do 10 slots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 30 times 29. Okay. So again, 10 slots. You have 30 people for the first choice, 29 for the second, 28 for the third, and so on. We can use that NPR button. So again, N is the total numbers on our calculator. This would be out of 30 people. We're choosing 10. And so let's do that in our calculator. It's faster. So menu, probability, it's a permutation, order matters. Out of 30, we're choosing just 10 people. So 30 comma, whoops, and 10. Okay, still a really, really big number, so you can see what that is. Again, I'm not going to write that down, but still a lot of different possibilities. Okay, how about these? How many different arrangements are there for the letters in these different names? We have Liam, so there are 4 letters, so here there's a few ways to do this. 4 times 3 times 2 times 1. This is the same as 4 factorial, which we figured out was 24 ways. 24 different ways to rearrange the letters in the name Liam. How about in Ella? So here there's 1, 2, 3, there's 4 letters, but there's 1 repeating. So if there's repetition, there's another way that you can do this. We have 4 letters total over, we have how many are being repeated. So we have 2 factorial. This is the number of letters being repeated. Okay, so what would that look like? And again, we could write this out. This is 4 times 3 times 2 times 1 over 2 times 1. So there's 12 different ways to rearrange the letters in the name Ella. Let's do a different name with more repetition. Let's just do Mississippi. How about Mississippi? Okay, so this has a bunch of repetitions. So first you count how many total letters there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we have to divide by the repetition. So take a look at each letter. Let's look at I first. 1, 2, 3, 4. There are 4 I's. So we're going to do 4 factorial. There are 4 S's. And there are 2 P's. So every letter that's being repeated, you have to write that as a factorial. So again, here's the number of S's, the number of I's, the number of P's, and then you can type that in your calculator. So let's try that. 11 factorial divided by parentheses, whoops. And we have 4 factorial. And then we have it again. And we have 2 factorial. And you can write those things in the bottom in any order as long as they're in parentheses. And there's 34,650 ways to rearrange the letters differently in the words Mississippi. All right, so your assignment is in your packet. Let me know if you have any questions. We'll go over them tomorrow.